Sorry to interrupt.
Yes.
Okay, with immense pleasure, I would like to introduce to you all Dr. Muhammad Hossein, Shakar from Uni Nov, which is Nov de Julho University, Brazil. Now, I would like to invite him to present a talk entitled The Effect of Control Oxidation Stress with Macrophages Investigating the Anti-Inflammable Potential of Photobiomodulation. Doctor, the floor is yours. Thank you.
Yes, thank you so much. My name is Mohammad, and today I will present my research titled Control Oxidative Stress with Hydrogen Peroxide in Macrophage, investigating the anti-inflammatory potential of the photobiomodulation. This project was developed under the guidance of Professor Cynthia Duran and Hakel Mesquita. Introduction. In this introduction, I wanted to give you the general context. We know that inflammation and oxidative stress are closely linked and play key roles in many acute and chronic diseases. Macrophages are essential immune cells responsible for detecting pathogens, orchestrating inflammation, and participating in the tissue repair. However, under the excessive oxidative stress, macrophage can become a dysfunctional, releasing excessive cytokines and damaging tissue. Photobiomodulation, or PBM, has emerged as a possible therapeutic strategy to modulate the response at the cellular level. In this study, we apply hydrogen peroxide-induced oxidative stress in the macrophage and test whether PBM at 660 nanometers could reduce or control this damage. Macrophage overview. Macrophages are highly versatile immune cells. Their primary role is phagocytosis, clearing pathogen and cellular debris. But they also act as antigen-presenting cells connecting innate and adaptive immunity. When activated, macrophage can produce cytokines, nitric oxide, and a reactive oxygen species, which are essential for a defense but can also cause tissue injury when uncontrolled. Therefore, a macrophage are an excellent model to study the balance between a defense and damage, particularly in the oxidative stress research, such study by Nathan and Dean cells in 2010 have showed the key roles of macrophage is non-resolving inflammation. In our experiments, we focused on the photobiomodulation as a protective tool. Macrophage J774A were exposed to the hydrogen peroxide to simulate oxidative stress. After that, apply PBM 660 nanometer. The parameter analyzing included cell viability, morphology, nitric oxide production, and pro-inflammatory cytokines such as TNF-alpha, EL6, and ENOS. The expected results were that PBM, which protect cell, increase their survival and decrease inflammatory mediator. So, in this study, PBM is not inducing phenotype switching, but rather acting as a cytoprotective and anti-inflammatory intervention. And what is our target in this experiment? The experiment had two main targets. First, we wanted to evaluate how hydrogen peroxide induced oxidative stress modulated macrophage inflammation and survival. And second, we tested whether PBM could attend these negative effects and improve connection outcomes. Together, this target help us to understand whether PBM has a therapeutic potential to control inflammation and support tissue repair in vitro. And you can see our protocol experiment. At first, we preparing and seeding macrophage cell in culture. Second, we preparing the hydrogen peroxide stock solution, and we working dilution at 500, 15, 100, and 200 micromolar, exposing the cell to hydrogen peroxide for 1 hour to induce oxidative stress, and then washing and replacing the medium, and we have applying PBM at 616 nanometer. And after that, we dividing in the experiment into the multiply groups with and without PBM. We incubation after a treatment. After that, we performing analysis such as viability, size, and microscopy, and cytokines detection, and finally, we organizing the data for statistical analysis. And then you can see our parameters in this experiment. The PBM parameters were carefully defined. We used the red light laser at 616 nanometer continuous emission with a power output at 700 milliwatts. The distance between the source and the cell was about 2 centimeters. The energy distance delivered was 3 joule per square centimeter, corresponding to the export time of 15 seconds. These parameters are constant with the tropical windows described in the literature, especially humbling and another photobiomodulation research. And you can see the experiment group was organized as follow 3 groups. First one is control group with no hydrogen peroxide and no PBM. Second was group exposed to hydrogen peroxide alone at 15, 100, and 200 micromolar. And at the end of the groups exposed to hydrogen peroxide followed by PBM at the same concentration. So cellulose was incubated after treatment, and different sizes were performed to evaluate oxidative stress and inflammatory outcomes. And you can see our result, our primary results using the emitted size. Size measures cells metabolic activity and is literally used to assess viability. The expects increasing and concentration of the hydrogen peroxide, a dose-dependent reduction in the cellular viability. At a 200 micromolar, viability was clearly compromised and conforming the effectiveness of our oxidative stress model. Interesting in the group that received the PBM after hydrogen peroxide was observed at a trend of the improved viability compared to hydrogen peroxide alone. The PBM only group did not show toxicity and mentioned viability similar to the control. And from this primary result, we can draw some interim conclusion. First, the protocol successfully induced oxidative stress in macrophage and validating our experiment model. Second, PBM at 660 nanometer demonstrated a potential of cytoprotective effect uh, to the lost cellular viability caused by hydrogen peroxide. And these results support our two hypothesis that PBM can modulate the cellular response to oxidative stress. And the next steps include completing the other analyses, such as nitric oxide quantification using degrees size and cytokine measurement by ELISA. And we also plan to increase the number of the replicated to statistical significance. Together, these data will allow us to establish a clearer link between ppm, oxidative stress, and inflammation control. And I want to thank to all my professor and my classmates to help me to present my work. Thank you.